To summarize Lesson 2 in Unit 7, an arithmetic sequence process here, we have a parking ramp example where we want the following space requirements. Row 1 has 4 spaces and each row has 2 more spaces than the previous row. So they want us to complete the following table. Well, if row 1 has 4 and each row has 2 more, then that means row 2 has 6, row 3 has 8, row 4 has 10, and row 5 has 12. What type of sequence is this? Well, since we're reviewing arithmetic sequences, it would follow that it is arithmetic. But they want to know why, and that's because you add 2 each time, and the adding part is the key. Arithmetic means an addition to each entry. Now we want to write a recursive and a function formula using the subscript notation for recursive and the function notation for the function equation. So we're going to use, since they're saying n and n minus 1, we know n minus 1 would be like the previous row. So we're going to say the row next, or the row sub n, our row sub now, or n minus 1, plus 2, because we're out of time. Remember, recursive always needs your original starting value. So that'd be r sub 0 would have, actually, r sub 1 would have 4 parking spaces. Now, for function notation, we have r, how many spaces in each row, r sub s, equals, our 2 goes here now. It's kind of like a linear. You know how it's growing by 2 each time? It's kind of like a line that has a slope of 2 every time. So we're going to have 2 times s. And in this case, because we know we want this to work, we said if function equation should help you by saying if I'm in row 17, how many spaces are there? Well, that's only helpful if it works for everything in our table. So we go up here. In row 1, there should be 4. Let's plug in 1 and see if we get 4. Well, 2 times 1 does not make 4. So I'm going to say, well, to get from 2 times 1 to be 2, I'm going to add 2. And if I try plugging it in here, so if I would take, like, for example, row 3. If I put 3 in here, 3 times 2 is 6, plus 2 would make 8, and that is how many there are. It works for 4 also. 4 times 2 is 8, plus 2 is 10. This is my function formula. There are times where they use, like, a step back, and so your equation could be 2 times s minus 1 plus 4. This allows someone to use that initial term. So there's your 4. It allows you to use that starting value of 4. And let's see if it works. If I would plug in, say, my number 2. If I want the second row and I plug 2 into my equation, 2 take away 1 would be 1, times 2 is 4, plus 4 would be, I'm sorry, put your 2 in here. 2 minus 1 is 1. 1 times 2 is 2, and then 2 plus 4 is 6. Either of these equations work. We probably use this one a lot more, but you just have to create an equation that with data you already wrote out, it actually works. So again, if I plug in 5 to either one of these equations for s, it should spit out a 12, and it does. That's helpful when we come to row 13. So when I go to 13, I've checked it for the first couple of rows there of my data. All I have to do now is pick one of those equations. I'll pick the top one and put 13 in for my s, and then add 2. So 13 times 2 is 26, plus 2 would be 28 spaces in row 13.